right, so we're going to start talking about something called function notation. So when we're normally talking about functions, we're used to seeing them as like, so for this example, I have 3x plus 1 here, right? We're used to seeing y equals 3x plus 1. That is our standard notation. We are trying to figure out what y is. We're setting y equal to x. So let's say that I wanted to know what does y equal when x is 2. So I would plug in 2 for x, right? I would say y equals 3 times 2 plus 1. So y equals 3 times 2 is 6, plus 1 is 7. So I would have that y equals 7. Okay, so when x is 2, y is 7. But the problem that I have with this, and it's not a big problem, but it's a problem that I have, is that when I get to the end of this, all I have is my output. The only thing that I have left is what I get out when I plug a number in. So we're going to talk about function notation, and what function notation does for us is it allows us to have our input value and our output value in the same answer, at the same time. So, I'm going to erase this circle that I made for myself here. I have this function in function notation right here. And the way that I say this, I'm going to write it out here, is I say f of x equals 3x plus 1. So the way that I say this is f of x is 3x plus 1. Now I have 3 different components to my function notation. So my first one is this f, right? I have f of x. Well, my f is just the name of my function. It's what I decided to name my function. So a lot of times, most of the time, you're going to see f of x. We choose the letter f because function starts with f, right? Kind of makes sense. So most of the time we use f of x. But the number before my x in parentheses really doesn't matter because I'm just naming my function something. So you might also see s of x. You might see t of x. You might see, I don't know, v of x. I can pick any letter to come before my x, and I'm just naming my function that. Okay? The letter that's in parentheses is telling you what my input values are. So in this case, my input values are all of my x values. So my x are my input values. And then when I'm done with that, I get my output, what happens when I plug it in. So, for example, if I have, in this case, f of 2. 2 is my input value. I'm going to plug 2 into my equation. Well, I did that over here. I already found out that y equals 7 when x equals 2. So I can just write f of 2 equals 7. Now, that's not what I wanted to do. I want a different color. Okay, so these two things say the same thing, right? My whole goal is to figure out what is my output. Well, my output in this case I have is 7. My output over here is also 7. The difference between these two ways of writing my solution is that in this case, I have my input value of x, and I have my output value of 7. In this case, over here, when I get to my solution, all I have is an output. All I know is that when I plug a number into some function somewhere, that I get an output of 7. The reason why we want to use function notation is because not only does it tell me that I get an output of 7, it also tells me that I put into my function. So I have some function f I don't know what it is in my solution, but that's okay. I have some function f. When I plug 2 into that function, I get out 7. So the reason why we use function notation is because it gives us more information than if we were to just stick with standard notation that just leaves us with y equals 7. This will get easier, I promise. It won't be so bad. So let's look at this worksheet. So my goal is I'm going to look at each of these functions and I want to match each function with its graph. Well, I'm going to do that in a couple different ways. So if you remember, the equation of a line is y equals mx. Oof. Let's try this over here. Y equals mx plus b. Where, why are you, this is not working right for me today. Okay. Where my m is my slope, we'll try this, I guess, I don't know. M is my slope, and b is my y-intercept. Okay, my y-intercept means that I'm crossing the y-axis, or the vertical axis, at that point. So this is like an equation for a line, right? So what I'm going to do is I'm going to look through my equations. Number one, I want to decide, is it a linear function or is it a nonlinear function? And then once I do that, I need to figure out, well, where is it going to be on a graph, right? So my first one is I have f of x equals 2x minus 3. Is this going to be a linear function or a nonlinear function? Well, if you remember, linear functions have x's that have exponents of 1. Nonlinear functions have x's with exponents that are not 1, right? So in this case, I have an exponent of 1 on my x, so I know that this is a linear function, first of all. It's going to form a line. The second piece of information that I need then is where is this going to cross the y-axis? Well, I have my equation of y equals mx plus b, right? And if you notice, it's plus b, but I have a negative number here. So what it's going to happen is I'm going to have my y-intercept is negative 3. It's going to cross the y-axis at negative 3. So when I look for a graph, I need to look for a graph that is a line, and I need to look for a graph that crosses the y-axis at negative 3. So if I look down here, I have two graphs that are aligned. B and D are both lines. Well, D is a line that crosses above the x-axis, which means that it's going to be a positive number. B, down here, I notice is crossing at negative 3. So the graph for letter A is going to be graph B. All right. My next one, g of x equals negative x plus 2. Again, I can say this one is going to be linear because x has an exponent of 1. My y-intercept, in this case, is going to be a positive 2. So if I look down here, I already used graph B, so it's going to be graph D because I can see that it's a line, but it does cross at a positive 2, so it checks out. So for letter B, I'm using graph D. All right, letter C. I've got h of x equals x squared minus 1. I know that because my x has an exponent that is not 1, that this is going to be a nonlinear function. Nonlinear. And even though it's nonlinear, this number that comes after is actually still going to tell me, oh no, is actually still going to tell me where my y-intercept is. So if I look at this, I have x squared minus 1. My y-intercept is going to happen at negative 1. So I need to look for a nonlinear function that crosses the y-axis at -1. Well, here are my two nonlinears. This one crosses at -1. This one crosses at -3. So my graph is going to be graph A. All right, and then our last one here, we've got j of x equals 2x squared minus 3. I also know that this one is nonlinear because it has an exponent that's not 1. My y-intercept in this case is going to be -3. By process of elimination, I know that this is going to be graph C, but I can go check that, right? So if I look down here at graph C, I have a nonlinear function that crosses my y-axis at -3. That checks out. All right, next page. So we're looking at this function, -x plus 3. So f of x equals -x plus 3. We want to locate each of these points. So my first one is at -1, f of -1. So if you remember, right, f of x equals y. That's what I'm looking for. X of x is the same thing as saying y. So in this case, I first need to figure out what is f of -1. Well, if I take f of -1, I'm going to plug -1 in. Here's the part that's tricky, right? I have a negative x, so I have a -1 plus 3. Two negatives make a positive, so I'm going to have 1 plus 3. So f of -1 is going to give me a positive 4. If I would write this as a point, I would have -1, 4. That's my solution. All I'm doing, this is the same thing that we've been doing, it just looks a little bit different because we're using different notation, but I'm just plugging numbers in for x at this point, right? I'm not doing anything special or fancy with them. So I'll do the same thing here, right? F of 0. F of 0 equals 0 plus 3. So f of 0 equals 3. My point for this one is 0, comma, 3. It's very straightforward. Don't overthink it. F of +1 now. So I've got f of 1 equals -1 plus 3, because I have a negative x as my function. So -1 plus 3 is a positive 2. F of 1, ooh, hello, equals 2. So my point for this one would be 1, comma, 2. Last one, I need to figure out f of 2. So I have f of 2 equals -2 plus 3. F of 2 equals 1. So then I have a point 2, 1. That's it. It's super straightforward. We're just plugging numbers in and seeing what we get out. So as we think about standard notation versus function notation, when I look at these two ways of writing the same thing, what do I notice is similar? Well, to me, the first thing I see is this 2x plus 5, right? I use the same expression in both. My same expression or function, my function is the same in both. What I notice is different, right, is that my f of x replaces the y. That's the second thing that's pretty obvious that I notice, right? My y becomes an f of x. Now the last thing that I want you to remember about this is that function notation includes input values and output values. Right, when I look at this, I know that my input values are x. I'm going to get something out that's f of x. So my function notation will include my input values as well as my exput value. I keep saying exput. Input values and output values. It has both. All right, we're going to do some practice with this. Let me clear this up here. All right, so this first part, I need to evaluate each of these when x equals -4, 0, and 2. So I'm going to evaluate them 3 different times. So my first one, I'm going to have f, hello. I'm going to have f of -4 equals -4 plus 4. I know that 2 negatives make a positive, right? So I've got actually +4 plus 4, which is going to give me 8. So f of -4 equals 8. Do the same thing with 0. F of 0 equals 0 plus 4. It would be a -0, but -1 times 0 is just 0, right? Which is just going to give me a +4. Last one, f of 2, -2 plus 4 is going to give me 2. F of 2 is 2. Do the same thing for g of x. G of -4 equals 5 times -4. 5 times -4 is -20, right? G of 0, I have 5 times 0 is just going to give me 0. Last one, g of 2, I get 5 times 2, which gives me 10. All right, h of x. So I'm going to have h of -4 equals 7 minus 2 times -4. 2 times -4 is a -8. So I have 7 minus -8. 2 negatives make a positive, so it's going to be 7 plus 8, which will give me 15. H of 0, 7 minus 2 times 0. Anything times 0 is 0, so my answer is just 7. Last one, h of 2, 7 minus 2 times 2 equals, well, 2 times 2 is 4. 7 minus 4 is 3. All right, I want you to do the next 3 on your own, so go ahead and pause this and finish the next 3, and then you can check your answers with me when you're done. All right, so when you're finished, you should have gotten these values for 4 through 5. So check your answers, make sure you got them right, and if you did not get them right, go back through and try to figure out where your mistake was. All right, so next, let n of t be the number of DVDs you have in your collection after t trips to the video store. Explain the meaning of each statement. So what I'm doing is I'm looking at each statement and I'm trying to think about it in terms of my scenario of going to the video store. So n of 0 equals 8. So I have taken 0 trips to the video store, which means that I start with 8 DVDs. in my collection. Right, I haven't even gone to the store yet, but I have 8 DVDs in my possession already. Next one, n of 3 equals 14. What that tells me is that after 3 trips to the store, you now have 14 DVDs. Letter C, n of 5 is greater than n of 3. This one's pretty straightforward, right? I have more DVDs after 5 trips than after 3. That makes sense. I've gone more times, so I'm going to have more DVDs. Letter D you could think of in a couple of different ways. So you could think of it as I have more DVDs after 7 trips than I do after 2 trips. The way that I kind of thought about it, though, is that I went to the store seven times and returned DVDs because I'm subtracting twice, and now I have 10. That was kind of how I thought about it. The book talked about how I go 7 times, and I'm going to have more DVDs after 7 times than I do after 2 times. But I think it makes sense to think about this in terms of returning things because I'm subtracting. Okay, let's move on. 8 through 10, I'm going to do maybe just 2 of these. I'll do 2 of these with you, and then you can do the other 2 on your own. So we want to find the value of x so that the function has the given value. So my function for number 8, I have b of x equals negative 3x plus 1, and I want b of x to equal negative 20. So I'm going to plug in negative 20 for b of x. So I would have negative 20, let's try to get further down, negative 20 equals 3x, negative 3x, oops, negative 3x plus 1. What I want to do is I want to figure out what my x is. Well, now I'm just going to solve like I normally do. Subtract 1 from both sides. I have negative 21 equals negative 3x. Divide both sides by negative 3. Negative 21 divided by negative 3 is 7. So I have x equals 7. So when x equals 7, b of x equals 20. So another way that you could write this is b of 7 equals negative 20. Either one of these is kind of what we're going for. B of x is negative 20 when x equals 7. So b of 7 equals negative 20. Let's do number 10 together as well. 10 has fractions. Fractions scare people, and then I'll have you do the other 2 on your own. So m of x equals negative 3/5 x minus 4. And I want to know what x value makes my function equal 2. So I'll have 2 equals negative 3/5 x minus 4. So I want to get rid of my 4. I'll add 4 to both sides. I get 6 equals negative 3/5 x. Divide both sides by negative 3/5. I'm going to multiply this by negative 5/3 and cross simplify. So that becomes a 1, that becomes a 3. So it gives me, oh, that becomes a 2. I was like, that doesn't seem right. That's a 2. So then I have negative 5 times 2. So x equals negative 10. Or m of negative 10 equals 2. Either way. All right, go ahead and complete numbers 9 and 11 on your own, and then you can come back and check your answers with me when you're done. All right, after you finish, you should have gotten, for number 9, that x equals 9, and number 11, that x equals -8. I did my workout there for you too, so you can check where you made a mistake if you got one of those wrong. All right, we have just a little bit more and then we're done. So, here we go. Come on. All right, we are going to graph the linear function. First, we need to fill in our table. So, s of x equals 1/2 x minus 2. So I need to figure out when x equals -4, what does s of x equal? So I have 1/2 times 4, which is times -4, is going to give me a -2. -2 minus 2 is going to give me a -4. Plug in -2 for x, I get -2 times 1/2 gives me -1. -1 minus 2 is -3. Plug in 0, 1/2 times 0 is 0, minus 2 is a -2. Noticing a pattern, right? -1 and 0. So then, I found it easier to like plot all of my points and then draw my line. So I've got -4, -4. Oh, man, this thing is, come on. Okay, there's 1 point. -2, -3. So, right. No, come on, right there. And then, oh, I forgot, we were gonna, okay, well, we can try to, where did my pen go? Oh, here. All right, so then I got 0, -2, oh, that one worked better. 2, -1, 4, 0. I'm gonna connect these the best I can. Oh, nice, hey, that's pretty good. Okay, there's my line, there's my linear function, I've graphed it. Do the same thing over here. So I've got 1 minus 2 times -2 is a -4. 1 minus -4 is going to be like 1 plus 4, so that'll give me 5. Ooh, I'm not going to fix it. 2 times -1 is a -2. 1 minus a -2 is going to give me a +3, going up by, down by 2 every time, right? So this will be 1, this will be a -1, this will be a -3. So then if I try to graph this, -2, 5 is up here somewhere. If I make a big enough dot, then it'll fit. -1, 3, 0, 1, 1, -1, and 2, -3. So then if I try to connect these, not bad. That last part wasn't great, but that would kind of be what my graph would look like. I'm sure yours looks much better than mine. Okay, this last one is a little bit tricky, I think. Kind of stumped me for a while. So the function b of m equals 50m plus 150 represents the balance in dollars in your savings account after m months. The table at the right shows the balance in your friend's savings account. Who has the better savings account? So I think the easiest thing to start with, right, is to plug in the months. So if I have b, if I have b of 2, right, I would have 50 times 2 plus 150, which would equal 250, right? 50 times 2 is 100. B of 4 equals 50 times 4 plus 150. 50 times 4 is 200 plus 150 would be 350. B of 6 then, I would have 50 times 6 plus 150, so 50 times 6 would be 250, plus 150 would give me 4. Did I do this right? 50 times 4 is 200. Oh, so it would be 300. This is why. Okay, 300. So it would be 450. I'm like, this doesn't make sense. Okay. Yes, 50 times 6 would be 300. Okay. So when I initially looked at this, right, I was like, okay, so after 2 months, I have $250 in my savings account, but my friend has $330. After 4 months, I have $350, they have $410. At 6 months, I still have less money. And so at first I was like, well, my friend has the better savings account, right? That would kind of make sense if we're looking at this. But let's take a look at how this is increasing. So my savings account, I go from 250 to 350, 350 to 450 every 2 months. So every 2 months, my savings increases $100. I increase $100 every 2 months. So that means that every month, I earn $50 more, right? Well, if I look at my friends, I go from 330 to 410, 410 to 490. I'm going up $80 every 2 months, which means that I'm going $40 every month. So they're making $40 every month. I'm making $50 every month. My savings plan is the better savings plan because eventually what's going to happen is I'm going to make more money than they do, and then I'm going to continue to make more money than they do because I'm earning $50 every month, they're earning $40 every month. Eventually I will surpass them, and so I have the better savings plan.